In this question, a convex lens of refractive index 1.5 is surrounded by two different media on left and right. Left side is air with refractive index 1. Right side is another medium with refractive index 4/3. Normally 4/3 is water. We're asking the focal length of the lens. The radii of both the surfaces are 20 centimeters. Assume the lens to be thin. So normally when radius of curvature and refractive index is given, we go for lens maker's formula. That is not applicable here because lens maker's formula, both the sides of the lens supposed to be of same medium. Its left side is air, right side supposed to be air. If left side is water, right side also supposed to be water. But this is left side and right side are two different media with the lens having a different refractive index. The only option is consider air to glass as one refraction, then glass to water is another refraction. So use refraction at spherical surface formula 2 times. The image formed by the first surface will act as a virtual object for the second surface. So refraction at spherical surface formula is N2 by V minus N1 by U equal to N2 minus N1 by R. If you consider the first surface for refraction, air glass surface, N1 is 1, N2 is 1.5, so U and V. V, we are supposed to find U, since they ask focal length, the concept of focal length for an object at infinity, U equal to infinity, there is a final image formed. That final image V, that is a focal length. For any system, focal length is defined for object at infinity. So if U equal to infinity, what's the value of V? We are getting the final image position, that will be the focal length. Final image position, not by the first surface. So the object distance for the first surface will be infinity. We have to find the image distance for the first surface, which will act as the object distance for the second one. So N1 is 1.5, N2 is 1, N1 is 1, sorry, N2 is 1.5, U is infinity, V we are supposed to find, R is plus 20 because the surface is curved to the right side. So we substitute the value 1.5 by V minus 1 by infinity will be 0. 1.5 minus 1 by 20 centimeters plus 20 centimeters. So this part will go 1.5 minus 1 will be 0.5. 1.5 and 0.5 will go 3. So 3 into 20 will be equal to 60 centimeters. Now considering second surface, for the second surface is a concave surface. N1 is 1.5. N2 is 4/3. U will be the V of the first surface, 60 centimeters. And the final image form, that's what you'd find as a focal length. Because final image position for object at infinity will be the focal length. Second surface, N2 is 4/3, N1 is 3/2, 1.5, U is plus 60. Because the first surface forms the image on the right side. V is what is supposed to find focal length. Substituting in the formula, 4/3V minus 3/2 into 60 in the denominator. 4/3 minus 3/2 by R will be minus 20 because the surface is curved to the left. 4/3 into V is F, 3/2 by U is 60 centimeter. 4/3 minus 3/2 by minus 20 because surface is curved to the left. So 4/3 minus 3/2, 6 will be the LCM. 2 into 4, 8, 3 into 3, 9, 8 minus 9/6. You can take this to the right also. So 4/3F equal to 8 minus 9/6 by minus 20 plus 3 by 120 minus 1 by 6, 8 minus 9. This minus minus will go, 6 will come in the denominator. So 1 by 20. 4 by 3f equal to 1 by 20 plus 3 by 20. 4 by 20 will come, 4 get cancelled. Then f will be 120 by 4, that will be 40 centimeters. That's a final answer. Important, you can't use the lens maker's formula because it's two different media on either side of the lens.